Yes, ma'am.
Hello.
Yes, ma'am.
So last lecture we have seen what is function, then how to find the composition of function. So today we are going to see how to find inverse of function. So there are four different steps to find inverse of given function. So first step is change f of x is to y. So here f of x is a function and we have to change that f of x to y. Second step, we have to swap x and y. So wherever we have written x, we have to replace that x by y and y by x. That is called as swapping of x and y. Then third one, solve the equation for y. So whatever equation we have obtained for y, we have to solve it. And finally, we have to change y to f inverse of x. So these are four different steps to find inverse of any function. So based on this, they have asked a question in the last year that find the inverse of following functions. Two functions were given and that question was for 8 marks. So likewise you have to solve. So here function is given as f of x is equals to 2x minus 5. So here for this function we have to find its inverse. So now first apply step number 1. So what is this step number 1? Change f of x to y. So here we have written f of x. So we have to replace this f of x by y. So y is equals to 2x minus 5 after applying step number 1. Now what is the step number 2? Swap x and y. So wherever we have written y, we have to replace that y by x and x by y. So according to the second step, our equation becomes x is equals to 2y minus 5. Now we have to apply step number 3, that is solve equation for y. Now we have to keep this y at one side and all remaining variables at one side. That's why we can move this minus 5 to this side. So it becomes x plus 5 is equals to 2y. Again we can keep this 2 at this side as y is equals to x plus 5 divided by 2. That's why now we have obtained a equation that is in form of y. That is only y is there at LHS. Now what is the next step? We have to change y to f inverse of x. So replace this y by f inverse of x. That's why inverse of this given function, that is f inverse of x, is equals to x plus 5 divided by 2. So in this way we can find inverse of function. Have you understood this problem? हॅलो, स्टेप समजलेत का? इन्व्हर्स कसा बघितलाय? Shall I repeat this once again?
I mean, yes.
Yes,
Yes, ma'am.
fine. So in order to find inverse of any function, we have to follow these 4 steps. So step number 1, we have to change f of x to y. So your given function will be in form of f of x. So first step, we have to change this f of x to y. So only we have to change this f of x. So here y is equals to 2x minus 5. This is after applying step number 1. Now, what is this step number 2? Swap x and y. So, what is meaning of swapping? We have to just alter the position of x and y. जिथे x असेल तिथे y लिहायचे, y असेल तिथे x लिहायचे. Now here, this is our current step. So here y is there. So we have to replace this y by x. And x is here. So we have to replace this x by y. That's why after applying step number 2, you will get x is equals to 2y minus 5. Now next one, solve the equation y. So first of all, we have to obtain the equation in form of y. Now here x is equals to 2y minus 5 is there. That's why we can keep this one as x plus 5 is equals to 2y. But we want equation in form of y only. That's why we can keep this y at this side as, now here it is multiplying. That's why after transforming this 2 to LHS, it will be dividing to x plus 5. That's why y is equals to x plus 5 divided by 2. Now we have obtained a equation that is in only form of y. Now we have to apply step number 4, that is change y to f inverse of x. So where y is written, we have to replace this y by f inverse of x, and that is equals to x plus 5 divided by 2. So f of x, this is the given equation, and f inverse of x, this is the inverse of this given function, and that inverse is x plus 5 divided by 2. Very simple steps are there, just 4 steps you have to follow. First one, whatever equation is given, in that equation you will get f of x. So first step, you have to change that f of x to y. Now second step, you have to swap x and y. You have to interchange the positions of x and y. Now third step, you have to obtain the equation in form of y only. And last one, you have to change that y to f inverse of x. And that will be inverse of given function. Understood now?
Yes, ma'am.
समझले का? Okay. So likewise again all these 4 steps we have to apply for this second example. If f of x is equals to x minus 2, then find its inverse. So again same steps we have to apply. What is step number 1? Change f of x to y. Okay. So f of x is here. So we have to replace this f of x by y. Now your equation becomes y is equals to x minus 2. Okay. Now till now just we have applied step number 1. Now what is step number 2? Swap x and y. That's why where y is written, we have to replace it by x, and this x should be replaced by y. So x is equals to y minus 2. So this is the result after applying step number 2. Now solve the equation y. So first of all we have to obtain the equation in form of y only. That's why we can keep y is equals to x plus 2. आता इथे minus 2 होता, इकडे जाऊन काय होणार आहे plus 2. That's why y is equals to x plus 2. Now we have obtained the equation in form of y only. Now we have to apply last step, that is change y to f inverse of x. Okay. So just replace this y by f inverse of x, and that is equals to x plus 2. So this is the inverse of given function. समजला का हा प्रॉब्लेम? Are you getting how to find inverse of function?
Yes, ma'am.
Okay. Now let us see third problem. If f of x is equals to x minus 2 cube, then find its inverse. Okay. So first, what is the first step? We have to replace this f of x by y. So y is equals to x minus 2 whole bracket cube. This is the equation after applying step number 1. Now what is this step number 2? We have to replace x by y by x. So this y is replaced here by x and x is replaced by y. So equation becomes x is equals to y minus 2 whole bracket cube. Now third step, we have to obtain the equation in form of y only. Okay, that's why here cube is there. That's why if you want to cancel this, you have to take this cube as x raised to 1 by 3 is equals to y minus 2. Again, we want to obtain this equation in terms of y only. So this minus 2 becomes plus 2 here. That's why y is equals to x raised to 1 by 3 plus 2. This is the equation in form of y only. Now we have to apply the last step, that is we have to replace this y by f inverse of x. That's why f inverse of x is equals to x raised to 1 by 3 plus 2. So this is the inverse for given function. Have you understood this problem? Hello?
Yes, ma'am.
Okay. Now can you try for this next question? F of x is given and you have to find inverse of this given function. So take 5 minutes and try for this example. Apply same steps. First, you have to replace f of x by y. Second, you have to interchange x and y. Third one, you have to obtain the equation in form of y only. And last one, you have to replace y by f inverse of x. So, take this example and solve it within 5 minutes.
Six by 5 into y plus 3 by 4. 6 by 5 into y plus 3 by 4.
X plus 3 by 4.
बरोबर तेवढं.
Hello, what is your answer?
X by 5 in bracket x plus 3 by 4.
No, that is not correct. I got 24x plus 18 divided by 20.
Ma'am, after simplification.
Yes, ma'am. 24x plus 18 upon
Yes,
20.
this is the correct answer. Why? See here, first one is we have to replace this f of x by y. So first we have to apply here y is equals to 5 by 6 x minus 3 by 4. Now we have to swap the position of x and y. So here y is there, that's why we have to replace this y by x. And here x is there, that's why we have to write here y. So we will get equation as x is equals to 5 by 6 y minus 3 by 4. Now what is the next step? We have to obtain the equation in terms of y only. That's why we can move this 3 by 4 here as x plus 3 by 4 is equals to 5 by 6 y. Again we want this equation in terms of y only. That's why we can move this factor here. So this 5 by 6 becomes 6 by 5. So 6 by 5 in bracket x plus 3 by 4. So before applying this 6 by 5 inside the bracket, we have to solve this bracket as 6 by 5 into 4x plus 3 divided by 4, and that is equals to y. So again 6 into 4x, that is 24x plus 18 divided by 5 into 4, 20. So this is the equation for y. Now apply last step as replace this y by f inverse of x. That's why f inverse of x is equals to 24x plus 18 divided by 20. So this is the correct answer. समजले का हा प्रॉब्लेम? Hello?
Yeah, ma'am.
Yes? Any doubt? Okay, no doubt. So now this example you have to try, and I want correct answer from you. So f of x is given as 4x minus 3 divided by 2x plus 1. So obtain inverse for this given function. Whatever steps are there, you have to apply and tell me correct answer. Hello. Have we solved it? What answer you got? Solve केले का? Hello. So here we have to apply step number 1. So replace this f of x by y. Y is equals to 4x minus 3 divided by 2x plus 1. Okay. Now what is next step? Replace x by y, y by x. So x is equals to 4y minus 3 divided by 2y plus 1. Now we have to obtain this equation in terms of y. That's why we have done this adjustment. This divider becomes here multiplier. So x into 2y plus 1 is equals to 4y minus 3. Now multiply this x inside, that is 2xy plus x is equals to 4y. Again I have taken this 4y minus 3 at LHS. So this plus 4y becomes minus 4y, and this plus 3 minus 3 becomes plus 3, and that is equals to 0. Now from these two terms, that is 2xy minus 4y, we can keep this y outside the bracket because y is common between these two terms. That is in bracket 2x minus 4 outside the bracket y plus x plus 3, that is equals to 0. Now again we can move this to right side as minus inside the bracket x plus 3. Here that becomes plus, so here on RHS it becomes minus, and 2x minus 4, that will be divided here. So this is the equation in terms of y. Now suppose I want to change this minus sign to plus sign. So here I can change it as minus in bracket 4 minus 2x. So what I did, just I have kept this minus sign common outside the bracket. So now if you apply, again you will get same term as minus 4, this minus minus becomes plus, so plus 2x. That is the same original equation, just I have kept this minus outside the bracket. Now this minus becomes cancelled, you will get y is equals to x plus 3 divided by 4 minus 2x. Now this is the equation in terms of y only. So now just we have to apply the last step, and that last step is replace this y by f inverse of x. That's why f inverse of x is equals to x plus 3 divided by 4 minus 2x. So this is the inverse for given function. Have you understood this problem?
Yes, ma'am.
Okay. So these kind of problems they may ask you in final exam to find inverse of given function. So just you have to apply these 4 simple steps. So if you want, take 2 minutes and take note of these 4 steps, because this procedure is not given in your textbook. So take down these steps. So later on also you can solve different examples by applying these steps. So here we have completed unit number 5, that is functions. Do you have any doubt regarding this unit? Have you understood all the concepts? Okay, roll it. So I hope you have understood all these points. Now we will switch towards unit number 6. So unit number 6 is algebraic systems. In that we have to see what is a algebraic system, semigroup, monoid, properties and examples of semigroups and monoids. So this chapter is also not lengthy. We will cover this within 15 days. So first point is a algebraic system. So hereafter you will get all the chapters quite in theoretical manner. So theory is there, examples are less, but theory, that is definitions and properties, those are involved more. So for each and every point you have to see what is the definition for same and what are the properties. So first point is a algebraic systems. So first we will see what is the definition for algebraic system. A system consisting of a set and one or more n-ary operations on set will be called as algebraic system or simply an algebra. So what is meaning of this algebraic system? So this system is consist of a set and one or more n-ary operations on set. So what is meaning of this n-ary? N is, it can be 1, 2, 3, 4 likewise. So one set and its associated operations forms a algebraic system. An algebraic system can be represented by S, F1, F2 and so on. So here we can say that S is a non-empty set and F1, F2, these are the operations, those can be performed on this set S. So this is an example of algebraic system. So what we have seen for definition, algebraic system is consist of set and one or more n-ary operations on that set. So here S is a set and F1, F2, these are the operations on set S. That's why this is an algebraic system. Now the operations and relations on set S defines a structure on elements of S, and that is called as algebraic structure. Algebraic structure म्हणजे काय आहे? Whatever operations and relations we have defined on set S, those will form a structure for the elements of given set, and that structure is called as algebraic structure. So here two definitions are given. First one is for algebraic system and second one is for algebraic structure. What is meaning of algebraic system? A system consists of set and one or more n-ary operations on set. That is algebraic system. And second one, what is algebraic structure? The operations and relations on set S defines a structure for elements of set S, and that structure is called as algebraic structure. Okay, so here two algebraic systems are given. First one is X composition and second one Y star. So here we can say that these are two different algebraic systems. Why these are algebraic systems? Because first element is set S. Set is there and operation is there. Again set Y is there, operation star is there. So this is an algebraic system. So these two algebraic systems are said to be of same type whenever n-ary operations, this composition and star, have same value of n. So here they have given when we can say that two different algebraic systems are same when both these operations, that is composition and star, will have same value of n. Same value of n means what? Suppose this composition is a binary operation, then this star must be a binary operation. If this composition is a ternary operation, then this star also a ternary operation. Then only we can say that these two algebraic systems are same. Hello, are you getting this? Hello.
Yes, ma'am. Repeat, ma'am. Ma'am, repeat कर.
Which one? Definition?
Example.
Example. Okay. So, two algebraic systems are given and we have to check whether these two algebraic systems are equal or not. So, what is the clue given here? So, these are two different operations. Composition, this is operation performed on first set, and star, this is the operation performed on second set. Then we can say that these two algebraic systems are same if the composition and star have same value of n. The same value of n म्हणजे काय? For this n-ary, n means what? n can be 1, 2, 3, 4 likewise. जर 1 असेल तर काय म्हणा बनरी ऑपरेशन, 2 असेल बायनरी, 3 ternary likewise. So here if this composition operation is binary operation, then this star operation should be a binary operation. Then only we can say that these two algebraic systems are same. Again, if this composition is a ternary operation, then star must be a ternary operation. Then only we can say that these two algebraic systems are same. म्हणजे काय डिग्री ऑफ कंपोजिशन, डिग्री ऑफ ऑपरेशन काही पण असेल, युनरी असेल, बायनरी असेल, टर्नरी असेल, जर ते दोन्हीकडे सेम असेल तरच आपण म्हणणार आहे दोज टू अल्जेब्राइक सिस्टीम्स आर सेम. समजलं का आता? फक्त ऑपरेशनची डिग्री चेक करायची आहे. जर ती सेम असेल तर त्या दोन अल्जेब्राइक सिस्टीम सेम असणार आहेत. Just definition is given here. Hereafter we have to solve the example. At that time again you will get clear idea. So again similarly here again two different algebraic systems are given. X composition plus, this is the first algebraic system. So here we can say that X is a set and composition and plus, these are two operations, those are performed on set X. So in the definition of algebraic system we have seen a system which is consist of set and one or more n-ary operation. Means what? We can define one operation on that set or we can define more than one operations on that set. So here this X is consist of, this algebraic system is consist of set X and two operations. Likewise second algebraic system is consist of set Y and two different operations. First one is star operation and second one XOR. So again we can say that these two algebraic systems are same when composition and star, those are having same degree, and plus and XOR, these two are having same degree. Then only we can say that these two algebraic systems are same. Concept समजली का? Hello. So next point is given as properties of an algebraic system. So this point is also very important because you will get question on this for 8 marks. Many times they have asked this question. So let I be a set of integers and consider the algebraic system I plus multiplication, where plus and multiplication, these are operation of addition and multiplication on I. In short, here one algebraic system is given, that is consist of set I, where I is a set of integers and two different operations are performed on this set, and those two operations are addition and multiplication. The properties associated with operations of addition and multiplication are labeled with letters A and M respectively. Okay. So whatever properties are associated with addition, those are denoted by A, capital A, and those are associated with multiplications, those are written with capital M. Okay. So here we have to define those properties. So first property is given as A1. A1 means what? This is the first property of addition. A is for addition. Okay. So for any three elements ABC belongs to I, in bracket A plus B plus C is equals to A plus in bracket B plus C. So here just we have changed the brackets. That's why this property is called as associativity. Okay. Hello. Sorry for inconvenience. Because of net problem, I got disconnected. So here we were seeing what are the properties of an algebraic system. So first property, that is for associativity. Hello.
Screen is not visible.
Hello.
Screen is not visible.
Hello. So now we have to see the second property of addition, and that is written as A2. So A is for addition and 2 means what? This is the second property for addition. So for any two elements A comma B, those belongs to I, A plus B is equals to B plus A. So this property is called as commutative property or commutativity. And third one is given as A3. So A is for addition, 3 is for third property of addition. So this property is for an identity element. So there exists a distinguished element 0 belongs to I such that for any A belongs to I, a plus 0 is equals to 0 plus a, that is equals to a. And here this 0 is called as an identity element. So this an identity element with respect to addition operation, because if you add 0 with any element you will get that element only, like 1 plus 0 is equals to 1, 2 plus 0 is equals to 2, 3 plus 0 is equals to 3, likewise. So if you add 0 with any element you will get that element only. That's why this 0 is called as an identity element for addition operation. So this is the third property. Now next property for addition is A4. For each A belongs to I, there exists an element in I denoted by minus A and called as negative of A. That is A plus minus A, that is equals to 0. So this is called as inverse element. So here minus A, this is an inverse element of A. So if we add element and its inverse element you will get 0 only. So consider example, if 1 is the given element then its inverse element is negation of 1, that is minus 1. So 1 plus minus 1 you will get 0. Likewise, if that element is 2 then its inverse is minus 2. So 2 plus minus 2 again you will get 0. So this is the inverse property. So there are 4 different properties for addition and 3 properties for multiplication. Now we have to see the next property, that is for multiplication. So here m is for 1. So m is for multiplication, 1 means what? This is the first property of multiplication. So whatever properties we have seen with respect to addition, same properties we have to see, but just we have to replace that addition by multiplication. So first property is same, that is associativity. So for any 3 elements A, B, C belongs to I, first bracket A into B into C, this is equals to A into B plus B into C. So again here we have changed just brackets, that's why this is a associative property. Now second one is commutative property, and that is for second property, so written as M2. So again for any 2 elements A and B belongs to I, A into B is equals to B into A. So this is a commutative property. And next one is that is for an identity element. So that is written as M3. So this is the third property of multiplication operation. So there exists a distinguished element 1 belongs to I, such that for any A belongs to I, A into 1 is equals to 1 into A, that is equals to A. So here we can say that 1 is an identity element for multiplication operation. So we can consider example, suppose this element A as 2. So 2 into 1 is equals to 1 into 2, that is equals to 2. Means what? If you take multiplication of any element with 1, you will get that element only. That's why 1 is called as an identity element for multiplication operation. For this addition, next property. Is this screen visible to you? Okay.
Yes,
So
ma'am.
next property is a distributive property. So that is represented here by D. D for distributive. For any three elements A, B, C belongs to I, A multiplication B plus C is equals to A into B plus A into C. So what we have done? So here just this multiplication is distributed over this bracket. Simple multiplication we have done. So A into B plus A into C. So this is a distributive property. And this is the last property, that is a cancellation property. So C is for cancellation property. So for ABC belongs to I, and if A is not equals to 0, then we can write A into B is equals to A into C. So again, whatever is common from both the sides, that is A is common here, so we can cancel it. If you cancel A from both the sides, then you will get B is equals to C. So this is called as cancellation property. So these are the properties of an algebraic system. 4 properties for addition, 3 properties for multiplication, 1 property for distributive, and last one is for cancellation. So this question is very important. Many times they have asked this question for 8 marks. So now tell me, do you have any doubt regarding properties of an algebra? Hello. Have you understood all these properties? If we have any doubt regarding any property, I can explain it once again. Any doubt? So I think you have understood. Okay. So here one question is given. First they have defined what is an algebraic structure, that we have already seen. The structure that is obtained by applying operations on given set, that is called as algebraic structure. Okay. So here set n is given where n is equals to 1, 2, 3, 4, 5 and so on. Then here they have asked whether n plus is an algebraic system. So or algebraic structure. So we have to check whether this one is an algebraic structure. So how to check it? So first of all, we have to see what is algebraic system for this given structure. So n comma plus, where n is a set and plus is a addition operation on that given set. That's why this one is an algebraic system. Now we can take any two elements from this structure or from this set. Consider 1 and 2. These are two elements. So now we have to apply this addition operation on these two elements. So 1 plus 2, that is equals to 3. Now check whether 3 is present in this given set. Okay, 3 is present here. So we can say that this system is closed under operation plus. That's why this is an algebraic structure. Again, if you consider any another pair like 3, 5, now apply the operation of addition on these two elements. So 3 plus 5, that is equals to 8. Now check whether 8 is present here in this set. Yes, 8 is here. After 5, 6, 7, 8, 8 will be there. That's why we can say that this set N is closed under operation plus. So this is an algebraic structure. Check कसं करायचं कळालं का? Whatever operations are given for that algebraic system, we have to apply those operations on any two elements, and whatever result you will get, if that result is present in that given set, then we can say that this is an algebraic system or algebraic structure. Hello? रिस्पॉन्स काहीच नाही आहे. काय समजते नाही समजते? काय प्रॉब्लेम आहे? जर तुम्हाला समजत नसेल तर आत्ताच सांगा, बिकॉज this is the second half of our syllabus and that is quite theoretical, so you might not be getting it, but just clear it to me here only. Hello? Okay, so here one example is given. Consider set B, which is consist of elements 0, 1. The operations of addition and multiplication are performed on B, and that is given by following table. So first table is for addition operation, second table is for multiplication operation. So now tell me, what is an identity element for this addition operation for first table? Which one is an identity element for first table? What is meaning of an identity element? So if you add that element with any element, you will get that element only. So for that we had seen one example. 1 plus, yes? Yes. What is your answer? Madhuri?
0.
0. Yes. So 0 is an identity element for this plus operation, and for multiplication
1.
1. 1 is an identity element. Correct. So now consider this example. Here composition table is given. From that you have to identify which one is an identity element. So 4 elements are there in set S: F1, F2, F3 and F4. So observe this table and tell me which one is an identity element.
F1.
Yes, F1 is an identity element. Correct. Okay. So here one example is given. Let X is equals to set which is consist of 4 elements 1, 2, 3, 4 and function f is defined from set X to X and which is given by set of order pairs. So first of all here we have to see what is the answer for F0 composition. F0, that is F1 0. So F1, F2, F3, these are the elements. So F0 composition F0. So what is the final answer? And this operation is of addition operation, that is composition. So here we have to just do addition of these indices. So F0 composition F0 means what? ऐसे index का है 0, 0 plus 0, 0. So you will get final answer as 0. Now next one, F0 and F1. If you take its composition 0 plus 1, that is 1. So final answer is F1. Next one, F0 composition F2. So 0 plus 2, it is 2. Again, F0 composition F3. So here 0 plus 3, that is 3. Okay. Now next one is F1 composition F0. So again 1 plus 0, it is 1. 1 plus 1, that is F1 composition F1. 1 plus 1, it is 2. That's why F2. Then F1 composition F2. Again 1 plus 2, that is equals to 3. So F3. Now here it is F1 composition F3. So if you take addition of these indices 1 plus 3, you will get 4. But here only 4 elements are there in given set and those are represented as F0, F1, F2 and F3. So now here addition of indices as 4. So 4 module divided by 4. We have to take module division. So 4 module divided by 4, it is 0. So answer for this composition F1 composition F3, it is F0. Now next one is F2. F2 composition F1. F2 composition F0. So again you will get F2. Then F2 composition F1, that is F3. Next one F2 composition F2. So again 2 plus 2, 4 is here. 4 module divided by 4, it is 0. Then F2 composition F3, it is F5. Now 5 module divided by 4, that is F1. Now for last row, F3 composition F0, that is F3 only. Then F3 composition F1. So again 3 plus 1, 4 and 4 module divided by 4, it is 0. That's why here answer is F0. Next one F3 composition F2. So 3 plus 2, it is 5. 5 module divided by 4, F1. And last one, F3, composition F3. So addition of indices is 6. 6 module divided by 4, it is 2. That is, final one is F2. So in this way, we can form table for composition of given functions. I think we have seen this point in function chapter also. Hello? हा प्रॉब्लेम समजलाय का? काय केले? Yes, 4 elements are there. That's why all the time while adding the indices, we have to take modular division with 4. आता प्रत्येक एलिमेंट साठी तेच करायचं होतं. सो पहिला एलिमेंट काय होता आपला F0. F0 कंपोजिशन F0, 0 मॉड्यूल डिवाइड बाय 4. आन्सर काय येणार आहे? 0च येणार आहे. नेक्स्ट वन F0 composition F1. So addition of indices is 1. 1 module divided by 4, it is 1. That's why answer is F1. Then F0 composition F2. So again 0 plus 2, 2. 2 module divided by 4, answer is 2. So it is F2. And F0 composition F3, 0 plus 3, that is 3. Module divided by 4, it is 3. So it is F3. So likewise, we can form a composition table. Now next part is very important, that definition for homomorphisms are given. Today we will see these definitions. So first of all, we have to see what is the concept of homomorphism. So let x0, that is x composition, and y star, these are two algebraic systems of same type. In sense that both composition and star, these are binary operations. So we have seen how to check whether two algebraic systems are same or not. If degree of these two operations is same, then only we can say that the algebraic systems are same. So here they have given that both composition and star, these are binary operations. That's why these two algebraic systems are equal. A mapping G is given from x to y. So mapping means what? Again it is a function, and that is defined from set x to set y. And this function is called as homomorphism or simply morphism from algebraic system x composition to another algebraic system y star if for any x1 x2 belongs to x, g of x1 composition x2, this is equals to g of x1 star g of x2. So this is the definition for homomorphism, and that is defined between two different algebraic systems. काय केले आपण? दोन algebraic systems घेतले. Again these two algebraic systems are same because these two operations, that is composition and star operations, are of binary operations, and one function is defined, that is function g, from x to y. So this function is called as homomorphism if for any two elements x1 and x2, those belongs to set x, if you apply this function g on those two elements as g of x1 composition x2, then you will get g of x1 star g of x2. So this is the definition for homomorphism. So I will So here one example for homomorphism is given. Two algebraic systems are given, G1 and G2. First one, G1 comma star means what? Star, this is operation performed on G1, and G2, here dot operation is performed on G2. So a mapping G is given from G1 to G2 is a homomorphism. So here they have given this is a homomorphism. Just a minute. So here we have to show whether these two are homomorphic to each other or not. So we can consider any two elements x1 and x2, those belongs to set X, or we can say those belongs to set G1. Okay. So here I have taken those two elements as A and B. So G of A star B is equals to G of A dot G of B. So we have taken this according to definition of homomorphism. So again they have defined here G1 and G2 as G1 is consist of four elements A, B, C, D, and star operation is performed on G1. After that, whatever composition table is there, that they have given here. Again, second table is for G2, and operation, that is dot operation, is performed on set G2. Now, consider two elements A and B. So, according to definition, what is the formula for homomorphism? G of A star B is equals to G of A dot G of B. Now check. What is the answer for A star B? If you consider G of A star B, what is the answer for A star B? It is B only. That is G of B. And they have given G of B is equals to R. So value for LHS, it is R now. Now consider whether RHS is having same value, that is G of A dot G of B. So what is the value for G of A? And that is given here as S. And value for G of B is R. What is the value for S dot R? So here S dot R, and that value is R. So we can show here G of A star B is equals to G of A into G of B or dot G of B. That's why these two are in homomorphism with each other. So likewise we can check for any another pair. Now consider we want to check homomorphism with the help of pair B and D. Okay, so we can write this formula as G of B star D is equals to G of B dot G of D. Okay, now what is the value for B star D? B star and D, that is C. So what is the value of G of C now? G of C is Q. So value for LHS is Q. Now check for RHS. Value for G of B. G of B is R. And value for G of D, that is P. So R into P. So R dot P. What is value? Q. So again we can show here LHS is equals to RHS. So this is same for any pair of elements from these two sets. So we can say that these two algebraic systems are in homomorphism with each other. So first of all tell me whether you are getting this. How to check? Hello?
Repeat, ma'am.
No, ma'am.
No? Okay. So I will explain that example once again. Okay. So check here. Two algebraic systems are given, G1 and G2. Star operation is performed on G1, dot operation is performed on G2. So what is given? Composition tables for G1, G2 and all these functions are given. Just we have to check whether these two are in homomorphism with each other. Okay. Now if you consider set G1, that is consist of 4 elements A, B, C, D, and G2 is consist of again 4 elements, and those elements are P, Q, R, S. Okay. Now consider two elements from set G1, and those two elements are A and B. So apply the formula for homomorphism. Then G of A star B is equals to G of A dot G of B. This is according to the formula of homomorphism. Now we have to check whether these two are equal or not. So let us consider LHS. So what we have written in LHS? G of A star B. So first of all we have to find value of A star B. So A star B. What is that value? B here. So what we have done? G of B. Now what is the value of G of B? It is R. So value for LHS, it is R. Now we have to check for value of RHS, and that is G of A dot G of B. So value of G of A is S and value of G of B is R. That is we have obtained from here. So S dot R. Now check what is the value for S dot R. S dot R, and that value is R here. So we can say that here LHS is equals to RHS. So these two are same, or these two are in homomorphism. Now consider another pair. Suppose that B, D. Okay. जर आपण B हे दोन एलिमेंट कन्सिडर केले तर फॉर्म्युला कसा येणार आहे? A and D by B and D. So G is G dot G of D. Now hello, my voice clear to you?
No, ma'am.
No, ma'am.
Breaking.
It's breaking.
No, ma'am.
No. Now check it. Is it clear now? Okay. So now again we have to consider second pair, and that is B and G. B and D. So first one we have to find value for G of B star D. So value of B star D. B star and D. So that value is C. Now LHS is G of C. So what is value of G of C? It is Q. So that we have written here. Now check for RHS. Value of G of B. G of B is R dot G of D. It is P. So R dot P, that value is Q. So again we can say here LHS is equals to RHS. So these are in homomorphism. Now consider next pair as A and C. So again we have to apply same formula, that is G of A star C is equals to G of A dot G of C. So what is value for A star C? And that is C here. So now find value of G of C. G of C is Q. Yes. So value for LHS is Q. Now check for RHS. G of A. So G of A is S and G of C, it is Q. Now check for S dot Q, and that value is Q. So likewise, if you check for any pair of elements, you will get LHS is equals to RHS. That is, this formula is correct. So we can say that these two algebraic systems are in homomorphism with each other. Okay, so check for elements C and D and check whether you are getting same value for LHS and RHS. Network problem is there, that's why it is getting disconnected. So again this pair C and D, we can take C star D, and that value is C. So again G of C, what is the value for G of C? It is Q. So value for LHS is Q. Now check for RHS. G of C, value of G of C, it is Q, and value for G of D, it is P. So again Q dot P. So Q dot P, and that value is Q. So again here LHS is equals to RHS. So likewise you can check for any pair of elements, like you can take CD, AD. So if you check for that pair, you will get both LHS and RHS are same. That's why these two algebraic systems are in homomorphism with each other. So this is the example and meaning of homomorphism. कन्सेप्ट समजले का? होमोमॉर्फिझम म्हणजे काय? हॅलो.
Yes, ma'am.
Okay. So today we are going to stop here. Remaining points we will see next lecture, because of network problem it is getting disconnected again and again. So better we will stop here. Just give me presenting. Roll number 1.
Yes, ma'am.
2.
Yes, ma'am.
Roll number 2. 3.
Yes, ma'am. Too.
Okay. 2 and 3
Yes, ma'am.
both are present. 4.
I see.
Yes, ma'am.
5. Roll number 8.
Present, ma'am.
Present.
Okay. Roll number 9. Ten.
Present, ma'am.
11.
Present, ma'am.
12.
Present, ma'am.
13.
Present, ma'am.
14.
Present, ma'am.
15. 16. 17.
Present, ma'am.
18.
Hello, ma'am. Roll number 15 is present.
Okay. 17.
Present.
18.
17 present, ma'am.
Okay. 18.
Present, ma'am.
19.
Present, ma'am.
20. 21.
Yes, ma'am.
22.
Ma'am.
23.
Present, ma'am.
24.
Present, ma'am.
25.
Yes, ma'am.
26. 27,
Present, ma'am.
28, 29,
Yes, ma'am.
30,
Ma'am.
31, 32,
Present, ma'am.
33,
Present, ma'am.
34, 35,
Present, ma'am.
36, 37,
Present.
38,
Present.
39,
Present, ma'am.
40,
Present, ma'am.
41, 42,
Yes, ma'am.
43, 44, 45,
Yes, ma'am.
46, 47,
Yes, madam.
48,
Yes, ma'am.
49,
Yes, ma'am.
50,
Present, ma'am.
51, 52, 53, 54,
Yes, ma'am.
Yes,
Ma'am,
ma'am.
55,
53 present.
54 is present.
Yes,
Ma'am,
ma'am.
53.
53 is present. Okay.
Huh.
55,
55 is present, ma'am.
56,
Yes, ma'am.
57,
Yes, ma'am.
58,
Present, ma'am.
59,
Yes, ma'am.
60, 61,
Present, ma'am.
62.
Ma'am, 60 present.
Okay. 62,
Present, ma'am.
63,
Present, ma'am.
64, 65,
Present, ma'am.
66,
Present, ma'am.
67,
Yes, ma'am.
68, 69,
Present, ma'am.
70, so today's absent numbers roll number 5, 6, 7,
Ma'am, 6 present.
Ma'am, 51 is present.